Balance the following equation in basic solution using the lowest possible integers and give the coefficient of water. The equation involved CrO4 2 negative aqueous plus HSNO2 negative aqueous, producing CrO2 negative aqueous plus HSNO3 negative aqueous. So first, we need to balance this redox reaction in basic solution. So step 1 is to assign oxidation number. First, I'm going to rewrite the equation down here. And let's look at the first species. For CrO4 2 negative, it's an ion, and so for ion, all oxidation number must add up to the charge of the ion. So if we have X as the oxidation number of chromium and -2 as the oxidation number of oxygen, then we'll have an equation of X plus 4 times -2 equals the charge of the ion, which is -2, and solving this equation will give X equals +6. So the oxidation number of chromium in this ion is +6. Moving on to HSNO2 negative. So again, this is an ion, and so all oxidation number must add up to the charge of the ion. So if we have +1 as the oxidation number of hydrogen, X as the oxidation number of Sn, -2 as the oxidation number of oxygen, then we'll have the equation of +1 plus X plus 2 times -2 equals the charge of the ion, which is -1, and solving this equation will give X equals +2. So the oxidation number for Sn in this ion is +2. Moving on to the products, for CrO2 negative, this is an ion, so again, all oxidation number must add up to the charge. So if we have X as the oxidation number of chromium and -2 is the oxidation number of oxygen, then we'll have an equation of X plus 2 times -2 equals the charge of the ion, which is -1. And if we solve this equation, we got X equals +3. So +3 is the oxidation number for chromium in this ion. Moving on to HSNO3 negative. So all oxidation number must add up to the charge. So if we have oxidation number of hydrogen is +1, oxidation number of Sn is X, and oxidation number of oxygen is -2, then we'll have an equation of +1 plus X plus 3 times -2 equals the charge of the ion, which is -1. And then, solving the equation will give X equals +4. So +4 is the oxidation number of Sn in this ion. Here we move to the next step, which is the identified oxidation and reduction half reactions. In this redox reaction, first we see chromium going from +6 to +3 oxidation number, so that is a decrease in oxidation number, so we'll see that as the reduction half reaction. Moving on, we see that Sn going from +2 oxidation number to +4. So that is an increase in oxidation number, so we identify that as the oxidation half reaction. So once we identify the two halves, let's write it down. Moving on to the next step, we'll start by balancing out the elements that is not oxygen or hydrogen. So for the oxidation half, we see that on the left, we got 1 Sn, and on the right, we also have 1 Sn, and it's already balanced, so there's nothing we need to do. Moving on to the reduction half, we have 1 chromium on the left and 1 chromium on the right. So again, it's already balanced. Moving on to step 4, we need to balance out the oxygen by adding H2O if needed. So first of all, looking at the oxidation half, we see that there is 2 oxygen in HSNO2 on the left, and there is 3 oxygen in HSNO3 on the right. So in order to balance it out, we need to add 1 H2O to the left, and so that way, in total, on the left, we got 3 oxygen, so that's equal to 3 oxygen on the right. Moving on, we look at the reduction half. We see that there's 4 oxygen in CrO4 on the left, and 2 oxygen in CrO2 on the right. So in order to balance it out, we need to add 2 H2O on the right. That way, there will be a total of 4 oxygen on the right equals to 4 oxygen on the left. So that's it for step 4. Moving on to step 5, we need to balance out the hydrogen by adding H+ to the reaction. So here we're looking at the oxidation half. There is 1 hydrogen in HSNO2 and 2 hydrogen in H2O, so that's a total of 3 hydrogen on the left, and on the right, there's just 1 hydrogen in HSNO3. So in order to balance it out, we need to add 2 H plus to the right. That way we'll have a total of 3 hydrogen on the left, and that's equal to 3 hydrogen on the right. Moving on, let's look at the reduction half. We have 0 hydrogen on the left, and we have 4 hydrogen from 2H2O on the right. So in order to balance it out, we need to add 4 H plus to the left, and that way both sides have 4 hydrogen. Moving on to step 6, we need to balance the charge of the equation by adding electrons. So checking the charge of the oxidation half, on the left, we have HSNO2 with 1 negative charge plus H2O, which is neutral. So in total, we have -1 charge on the left. And now looking at the right, we have HSNO3 with 1 negative charge plus 2H plus with 2 positive charge. So that's a total of plus 1 charge on the right. So in order to balance it out, we need to plus 2 electrons on the right. That way it adds the -2 charge to the right to give a total of -1 charge. And that way both sides have -1 charge and is balanced. Now looking at the reduction half, we see CrO4 with 2 negative charge plus 4H plus with 4 positive charge. So that's a total of plus 2 charge on the left. And now looking on the right, we have CrO2 with 1 negative charge plus 2H2O, which is neutral. So that's a total of -1 charge on the right. So in order to balance out the charge, we need to add 3 electrons to the left. So that way it's a total of -1 charge on the left. And both sides are now balanced with -1 charge. Moving on to step 7, we need to multiply each half reaction by a coefficient to have the same number of electrons involved in each half. So we're looking at the oxidation half, we see that it released 2 electrons, and in the reduction half, it used up 3 electrons. So in order to balance out the number of electrons on both halves, we need to times everything in the oxidation half by 3. So that's going to be 3 HSNO2 negative plus 3 H2O, producing 3 HSNO3 negative plus 6 H plus 6 electrons. And for the reduction half, we need to times everything by 2. So that's going to be 2 CrO4, 2 negative, plus 8 H plus 6 electrons, producing 2 CrO2 negative plus 4 H2O. So that's a total of 6 electrons in both half reaction. Now moving on to step 8, we need to add the 2 half reactions together, and then we're going to cancel out the electrons as well as any other common terms. So to add the 2 half reactions, we just need to add the reactants together on one side and products together on one side. So first of all, we know we can cancel out the number of electrons because there are 6 electrons on both sides. So another common terms between the 2 sides is H2O. We have 3 H2O on the left and 4 H2O on the right. So we can cancel out the 3 H2O on both sides to be left with just 1 H2O on the right. Moving on, another common term is H plus. So we got 8 H plus on the left and 6 H plus on the right. So we can cross out the 6 H plus on both sides to be left with just 2 H plus on the left. Now moving on to the step 9, it is to add OH minus to neutralize any H plus and to convert the H plus into H2O. So in the reaction right now, we see that there is 2 H plus on the left. So that way we need to add 2 OH minus on both sides. And that way the 2 H plus will be neutralized by 2 OH minus to result in 2 H2O on the left. And we have 2 OH minus on the right. So now we see that again, the common terms in the 2 half is H2O. We got 2 H2O on the left and 1 H2O on the right. So we can cancel out the 1 H2O on both sides to end up with just 1 H2O on the left. So this is our final balanced equation. We have 3 HSNO2 negative plus 2 CrO4, 2 negative, plus H2O, producing 3 HSNO3 plus 2 CrO2 negative plus 2 OH minus. So to answer the question, The coefficient of water in the final balanced equation is 1 because there is one H2O in the equation. If you're interested in a PDF of the written detailed solution to this problem, please enter our giveaway. The detailed instruction on how to enter the giveaway is in the comment section. Please check it out.